Bisectors of triangles. We are talking about the same things we were talking about the other day, as in perpendicular bisectors. Now, recall perpendicular bisectors cut a segment in half at 90-degree angles. So the segment is congruent on either side. Now, also remember, because this is where our students earlier were struggling, is this segment is the same distance to the endpoints then. We all did that earlier, right? It's the same thing we're going to be talking about today. The only difference is we're going to talk about it in triangles. Same thing is true of angle bisectors. We did angle bisectors the other day. If I have an angle bisector, well, what's that telling me about my two angles? The two angles are the same. So if this is 20, this is 20. And then I also know that my angle bisectors are the same distance to the sides. It's the same thing we're doing. And again, we're putting it into relationship of a triangle now. Same work, looking at it in a triangle now. Okay? Vocab here. We're going to have some important vocab terms that will come up again. The first one is, what is concurrent? Concurrent means three or more lines that intersect at one point. So I have a line, and I have another line. They are concurrent because they intersect at one point. Concurrent means they are intersecting at one point. Now, the next one, which is a great one, is the point of concurrency. The point of concurrency is a point where the three lines coincide, or three or more lines coincide. That right there is the point of concurrency. That is the point of concurrency. So three lines or three or more lines can be concurrent. Where they intersect is called the point of concurrency. Now here's the ones we're going to be talking about today. These are the two you need to know. Don't cross it off. Circumcenter and incenter. Circumcenter is the point of concurrency of the three perpendicular bisectors. So what happens here is all of the perpendicular bisectors of a triangle actually intersect at one point. It's kind of unique. That point is called the circumcenter. All right, now there's a lot of unique properties on both of these items. Now I'm going to show you of a right triangle. Okay, so in a right triangle, if I have the perpendicular bisectors, look something like that, something like that, something like that. I have the... Oh, they're coming. They're on mine already. There you go. Wow. The perpendicular bisectors, they all intersect. Now, perpendicular bisectors are the point of the midpoint, perpendicular to the sides. That's the point of concurrency. Now, in a circumcenter, it's kind of unique. Now, I tried drawing this with a circle. I'm going to try one more time. We'll see if it works. But what's actually unique about this is... there you go. It actually is the same point that is equal distance to all the vertices. So a circumcenter is unique because it's the same distance to three vertices. Now, why is that important? Well, for example, let's say, DC West is going to build a new school with Valley, Waterloo, and all of a sudden they're going to add UTAN. Okay? And they want to make a centralized location. Well, if they take all three towns and form a triangle of it, they can find the circumcenter, which is then the center, which is equal distance to all three towns. It's kind of unique. Okay, a lot of different properties are used like this for surveying, architecture, great stuff. Anything like that. Again, circumcenter. It's equal distance to all the vertices. Okay. The other one is the incenter. The incenter is the point of concurrency of the, it says trine, but it should be three angle bisectors. So incenter is the point of concurrency for the angle bisectors. Now, what that means here is I'm going to show you a triangle again. I'm going to try and do a very similar triangle. Okay, so angle bisectors. Now, the unique thing of angle bisectors is angle bisectors, remember, are always equal distance to the sides. Okay, so what happens when I have an angle bisectors is... Oh, that's almost perfect right there. You get what is an inscribed circle because it's equidistant to all the sides on it, I can draw a perfect circle on the inside of a triangle, actually. Okay, now it's what's called the incenter, and that makes what's called an inscribed circle. So it's a circle in which each side of the polygon is tangent. Tangent means it runs right along without intersecting. Okay, so that's tangent. Notice the difference. Circumcenter, I can fit a circle around the triangle. Incenter, I can fit a circle on the inside of the triangle. Yes, sir. What? You don't see the circles?
I see circles.
Okay. The circumcenter is equal distance to all the sides, or to all the angles, like to all the vertices. So essentially what that means is that'd be like a radius. Like this is the same distance to there, which is the same distance to there, which is the same distance to there. An incenter is the same distance to all of the sides of a triangle. This incenter is what you get when you intersect, all the angle bisectors intersect. A circumcenter is what you get when the three perpendicular bisectors intersect. Okay? Those two are going to be key vocab terms. You will need to know both those two. So, circumcenter here. Let's show what this looks like in a triangle. Again, circumcenter is the perpendicular bisectors. Now again, perpendicular means right angle. Bisect means cut in half. So as you look at it here, you can see it cuts the sides in half. So I have congruent sides. That hasn't changed. Okay? We did this stuff already. We just did it in a part segments. Now we're adding it to a triangle. Okay? And again, what this says here is the circumcenter theorem. The circumcenter of a triangle is equidistant from the vertices of the triangle. So you can look right here and you see, here's my circumcenter right in the middle. That is going to be equal distance to all of the vertices. So that's equal distance to all of the angles in that triangle. That's what you need to know. Okay? After that, then we still remember this part. Well, because they're perpendicular bisectors, it cuts it in half. My sides of my triangle then are cut in half, so they're going to be congruent. Those are the same properties we've talked about. Okay, let's look at a problem here. Number 1. HD, JD, and KD are the perpendicular bisectors. We're talking about perpendicular bisectors. Good. Perpendicular bisectors. I want to find each length. First length I want to find is DG. So there's D, there's G. I want to find that length in purple. Now again, perpendicular bisectors, the intersection here is called a circumcenter. So let's see here. There's my circumcenter right in the middle. And I want to find the length from D to G. Does anybody think they know the length? Trev? It would be 19. Why? Because the length from F to D is 19. So this one has to have a length of 19 as well. Because it's the same distance to those vertices. So again, same distance to the vertices. Okay? So again, yeah, DG is 19. Well, let's try EK now. I want to find EK. So I want to find this distance right down here. Well, who thinks they can figure out what EK is? Tina? It is 17. Nice job. Because, again, DK is a perpendicular bisector, cuts the segment in half, so EK has to be 17. Well, FJ now. Let's do FJ. FJ is right here. What do you think FJ is going to have to be, Nick?
16.
No, sir.
Wait.
Look at the segment it cuts in half.
19. I don't know. 15.
It's 15. Nice job, Johnny. That would be 15 because it cuts this segment, this whole segment right here in half. So the other half is 15. FJ has to be 15.
Oh,
okay. And then the very last one, I have DE. So I want to find this segment right here. What does DE have to be K? 19 is correct. Nice job. Again, circumcenter is going to be equal distance to all of those sides. Do you understand that?
Excuse me, teachers and staff.
All right. Next one here. Well, we can do circumcenters of triangles on the coordinate plane. Now, circumcenter means that is the what? Circumcenter is made from what part? No, what lines? There's specific. There it is. Circumcenter is made from the perpendicular bisectors. Okay, that is made from the perpendicular bisectors. Good. So, perpendicular bisectors, remember, perpendicular, 90-degree angle, cuts it in half, bisects, cuts in half, right? On a coordinate plane, if I have a horizontal line, a perpendicular line would be a, anybody? Vertical line. So, for example here, there would be a perpendicular bisector to that line right there. In a coordinate plane, that all makes sense, right? If it's horizontal, perpendicular is vertical. That makes sense, right? 1, 2, 3, 4, Tina? Tina, this is the distance of 2 then? Here's the distance of 2?
No, and then what if we go...
Oh, yes, ma'am. Thank you. I got you. So then over here, I'm going to do the perpendicular bisector, which would go right there, right?
Yeah.
Perpendicular bisector. Does everybody see how they're perpendicular, vertical lines, perpendicular to horizontal, horizontal, perpendicular to vertical? So I'm looking for the point of concurrency. Well, if you look, it's on the edge of it, actually. So I'm looking for that intersection right there. They actually intersect at what point then, Ryan? 2, 3. Nice job, sir.
And that's all we have to do?
That's all you have to do there. You just have to find where they intersect. So the circumcenter is where the perpendicular bisectors intersect, which is that. Yep. That is not. It's somebody's from last class, actually. So perpendicular bisector, you see it now? So if I look down here at this bottom, I have a distance of 4. So I cut that in half, right? 2. You with me now? Okay. So let's do the next one over here on the right. So I have my bottom segment, which goes from -8, 0 to 0, 0. My perpendicular bisector would go through what, Troy? Yeah, it'd go right through -4 right there. Now let's look at the other segment over here. Perpendicular bisector would go through what, Troy? 2.5, 0. Nice job. So I'm looking for my perpendicular bisector. Well, they intersect at that coordinate right there. So the point of intersection would actually be what?
What?
Oh, I thought you were asking.
Oh, I can answer.
What do you got?
-4, 2.5.
Nice job, sir. That is correct. And recognize, now this is kind of one of the unique things. Every time in a right triangle, the circumcenter will always be on the opposite line, actually. And if you see them, they actually do meet up there. In a right triangle, that is always true. All right, next thing we're going to talk about is an incenter. Now remember, incenter is the parts of the angle bisectors. So angle bisectors are what form the incenter. So an incenter of a triangle is equidistant from the sides of the triangle. So if you look here, all of these are equidistant to the sides of that triangle. Okay? Again, we did the same stuff the other day. The only thing the other day is we talked about one angle. Now we're talking about with 3 angles and a triangle. It's still the same work. Okay? Now understand, angle bisector, the angles are congruent. Do we all understand that? Cuts the angles in half, angle bisectors. Okay, so those 2 things are what we're going to have to know. This shows how we can solve for some different parts. So one thing here is, I know the distance from W to K. That's 21. Does everybody agree with that? That's given to me.
Yes, sir. Yep.
So if I wanted to find the distance from W to NP, so I want to find the distance to the other side, what's that distance have to be? 21. Yeah, this distance has to be 21 because it's the same. What's the distance from W to MN have to be? 21 as well. Again, incenters are equidistant to all of the sides of the triangle. All right? Now, the other part is I can find missing angles in here. For example, I'm given this angle 72. I know this angle here is 32. What's the angle next to 32 have to be?
32.
Why?
Because that has to equal 62. 64. It has to equal 64.
Because, no, it's 32. You're right, it is 32. But why is it 32? Because this line is in bisector. I have an angle bisector. Bisect cuts in half. So that means my angle M is a total of 64. From here, they show you, well, then I can solve for this angle over here. How can I find that angle? And subtract from?
180.
Nice job, sir. Yeah, they see that here. You know, a triangle adds up to 180. That's still the same. We've talked about that a lot. So this angle there is 44 degrees, but it wants one of these small angles. What do you have to do to find a small angle then? Cut it in half, divide by 2, and you get a 22-degree angle. Whew, a lot of information there. But it's all the same things we have been doing, just tying it all together in one. Let's try number 7 here. I want to find the distance, PC and PD are angle bisectors. We're talking about angle bisectors. The distance from P to CE. So I want to find the distance from P to CE there. What do you suppose that distance is going to be, Austin?
9.
Nice job, sir. That has to be 9. I know P to the other line is 9. So P to the other line has to be 9. They're all going to be the same, right? Good. Now comes the tough part. I want to find the measure of PDE. So PDE. I want to find that measure right there. Okay. I'm going to have to fill in some information here. Does everybody agree I'm giving this angle is 40 degrees? I know that. I know this angle is 36. What's the angle next to that have to be? 36. Which means angle C is actually going to be? So how can I find angle D over here then? So 180 minus 40 minus 72. 180 minus 40 is 140. 140 minus 72 is 68 degrees. So I know the big angle is 68, but I want the small angle. What do I have to do with that 68 to find the small angle? Divide it by 2 because it's angle bisectors. Nice job. Divide that by 2. And PDE is then 34 degrees. Nice job. Good work. All right, we're going to try number 9. Number 9 is very similar. I'm looking at the bottom triangle now. The distance from K to YZ. Oh, sorry, I missed it again. KX and KZ are angle bisectors. So recognize angle bisectors cuts the angles in half, forms the incenter. I want to find each measure. So I want to find K to YZ. So this distance right there, K to YZ. What will that distance have to be? Gabe, what do you say? Angle bisectors, right? Same distance to the sides. So I'm given one of the lengths up there. What's that length I'm given? So what's the distance from K to the other side have to be? 33. Because angle bisectors are the same distance to the sides. Okay? Good. Now I want to find KZY. So I want to find KZY. I want to find this angle right here. It's going to be a very similar problem to the one we just did on 8. What do I know? I know Y is 39 degrees. Everybody see that? I know this small angle is 18. What's the angle next to it have to be, Tyler? 18. which means x is going to be a total of what, Tyler?
36.
Thank you, sir. 36. So to find angle Z, what am I going to do? 180 minus 36 minus 39 equals, what's that going to equal?
I have it.
Troy? Subtract from 180?
Troy.
105, thank you, sir.
Good job, Troy.
So that gives me the big angle there, but I want the part angle, which means I need to divide by 2, and I get 52.5 degrees. Whew, a lot of information there, I know, but it's still the same thing. Angle bisectors, cut angles in half, equal distance to the side. Perpendicular bisectors, congruent to the end points, the vertices. Notice the difference in the two. Try these 4. This is dealing with the circumcenter. Recognize, I'm talking about the circumcenter now, which is the perpendicular bisectors. Take a couple seconds to try these. All right, Noah, number 11. Want to find the distance from A to G. So I want to find this distance right there. What do you get, Noah? Nice job, sir. That is 10. Because this is 10 over here, that has to be 10. Good work. Anna, AF. I want to find the distance from A to F. What do you say that is? 9.8. Nice job. How do I know that? Well, the other side is 9.8. That has to be 9.8. Nice job. Just a show. That's fun.
It's Christmas time.
DB. I want to find the distance from D to B here. What do you say, Drew? 7. Nice job. This is 7. This has to be 7. And the distance from G to B. So I'm going from G to B here. What does that have to be, Ryan? Nice job. 10. That's the circumcenters.
That's like 11.
That's 11.
Oh, it's coming 10 on my screen.
It's 10 on your computer.
It's 10 at Swift's.
Spence is killing
It does say it's 10.
It says 10. That is weird, though.
There it goes.
There it is. There's 10. All right. Try these 4. This is the incenter now. Incenters are the angle bisectors. Angle bisectors. All right. Try these 4. All right. Number 15. The distance from K to JI. What's that distance going to be, Jack? Nice job, sir. Number 16. The measure of angle HJK. HJK, Camden?
45.
45 degrees. Good. Number 17. The measure of JHK. JHK is going to be what, Tom? 30 degrees. Nice job. And the very last one, the measure of HJI. Well, I'm looking for the big angle now. HJI is what, Troy? 90 degrees. Not bad. For a bonus question, what does I have to be then? Anybody know what I is?
Yeah.
Oh, what do you got, sir? 30 degrees is correct. Yeah, I heard you say it though. Nice job. Nice work.
Troy, don't put your hand down.
Here is your assignment.